All right, here's a practice test for Chapter 5 for College Algebra. Write in standard form. Right now this is in factored form. There's three linear factors here, x minus 3, x plus 2, and since it's squared, it's x plus 2 again. All right, so we're going to multiply this out. So I'm going to cover this one up, multiply these two together first, because we can't multiply two things together at once, or three things together at once. X times x is x squared. 2x, this and this makes 2x, and then 4. So I get x squared plus 4x plus 4. So it's always better to kind of put those like terms together before we bring in the last term. So we're going to do x times each one of these. So it's going to be x cubed plus 4x squared plus 4x. Now I'm going to do negative 3 times each one of those, negative 3x squared minus 12x. Minus 12. Put together the like terms. This and this go together. That makes x squared, or 1x squared. This and this go together. Minus 8x. The 12 doesn't have a partner there, so it's minus 12. And then plus x cubed. And that's what f of x is equal to. So this is the standard form all multiplied out. This is factored form up here. They are the same thing. You could check your answer by graphing and see that it made the same graph. When there's a bounce like this, it has to have a even number of times, a multiplicity of 2. It could be a multiplicity of 4 or 6 or 8, but we'll just do 2. So the roots are x equals 1, x equals 5, and x equals 3 with a multiplicity of 2. So that one is a copy solution. So x minus 1, x minus 3 squared, because it happens twice, and then x minus 1. So when you see that bounce, that's a multiplicity situation. Now, there could be a different number here in front. We need another point to figure out whether there's a different number in front. So that's what this question is about. What is that number in front? So this is a 0. This means x plus 1. That would be the factor. This means x, because x equals 0 would be that solution. And then x minus 2 and x minus 4. So those are the zeros of the solution. Those are the factors associated with these zeros. We don't know what that mystery number is in front, and then that would be equal to y. So we're finding the polynomial. So we're going to nail down that. So we have 1, 2, 3, 4, and then this would be the fifth point. 5 points make x to the fourth, which is what this is. So y is 63, and we're going to put in a half. So it's a times a half, and then put a half here, so it'll be 1.5. Put a 1 there, so it'll be negative 1.5. And then put a half there, so it'd be negative 3.5. So we multiply all that together. Multiply all this together, and it's going to be positive because it's a negative times a negative times that times that. So for time purposes, I just have the answer key here. So multiply all that together, and you get 3.9375. Keep all the decimal points, because you're going to divide that into there, and that's going to go in there 16 times, amazingly enough. So a is 16. So my answer for this is y is equal to 16x, x plus 1, x minus 2, and x minus 4. So this polynomial holds these points and that point right there. All right, now we're going to pretend that this equals 0. So x plus 1, x minus 3, and x minus 5 is equal to 0. So the interesting points are 5. So I'll put 5 on the number line. That's where it's equal to 0. So that happens to be an open circle because it's not, we don't want equal. 3 is the next interesting point, and that's where it's 0. And then negative 1 here. So negative 1, whoops, makes it 0. So I have a number line, and I just cut it in 3 places, making 4 parts. So then I say, okay, what works? If I put a big positive in here, this would be positive, this would be positive, that would be positive, which is greater than 0. So this part here would be shaded. Then I would try 4. This would be positive, this would be positive, and that would be negative. So this if I put 4 in, I'm going to get a negative, which is not greater than 0. So that interval doesn't count. Then if I put 0 in, this would be positive, this would be negative and negative, but it means the whole thing would be positive because a negative times a negative is positive. So this interval works. And then when you test this interval over here, it doesn't work as well. So it's not equal to 0, so I don't make solid circles there. They're open circles, so I use parentheses. Parentheses -1, 3, parentheses, union, and then 5 on the left side, smaller number on the left, bigger number, right? Smaller number on the left, bigger number on the right. Smaller number on the left, bigger number on the right. Union, right? This is unioning them together, the two sets. They're separate from each other, so you got to union them together. It's a union of set matrimony. All right. So again, this is equal to 0, so 5 minus 5 would make it equal to 0. So 5 is an interesting point, and it is a 0, and it's a place that works. So I make it a solid circle. The next two interesting points are plus or minus 2, because those would cause division of 0. So put in 2, open circle, that's where it blows up, and -2, open circle, that's where it blows up. All right, so we're going to start testing points into this. If I put in a big positive number, it's going to be positive over positive, which means it works on this interval. If I put in 3, it would be positive on the bottom and positive on the top, so it works on this interval too. So this is one of those where it's going to come down and touch 5 and leave. So that would be a place where it bounces off of it, and that makes sense because it is squared. The next place would be down in here. If I put 0 in here, I get negative and positive on the top. So no, that's not less than 0. It is less than 0, not greater than 0. And then when I test this point down here, or a point down here, it works. So it's from infinity to -2, union 2 to infinity. And that would be the intervals that work for that. So there wasn't really a lot of algebra to do with this because it's pretty much all solved out. Okay, so this one here, I did it differently on the answer key. I would probably do it this way. So we pretend that it equals 1, and then 1 over 1. Whoops, sorry. There we go. So we're going to pretend that it equals 1, and then go back and figure out when it's greater than 1. Cross multiply x plus 2 is equal to x minus 4. So these are the places where it is where we cross multiply, and basically this would be equal to this when we cross multiply because 1 over 1 makes the proportion. Subtract x over, we get 2 is equal to -4. Well, there's no solution to that. So that means there's only one interesting point, and that's where you divide by 0, where it blows up, and that would be at 4. So 4 is the only interesting point here, and that's the blow up point where the function blows up. And then we go, okay, if I put in a big positive into this, it would be positive, like put in 10, it'd be 12 over 6, which is 2. So it works on this side. But it doesn't work on this side because if I put 0, I get 2 over -4, which is a negative number. So 4 is greater than or it's greater than 4. So I use, because it can't be 4, so it's greater than 4. So I use parentheses 4 to infinity. Okay, next one. We're supposed to show all of the potential zeros. So it's P over Q. So we do P over Q, make it better, Q, there we go, is 6 over 4, which is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, over plus or minus 1, plus or minus 2, plus or minus 4. So what you have to do is you have to go through and you have to do 3 separate things. You have to divide everything by 1 first into the top. And then you got to divide everything by 2, plus or minus 2. And then we'll go pink here. Got to divide everything by 4. So you're going to get all of these, with these pool of guesses that we talked about. Pool. So dividing by 1 doesn't do anything. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now we're going to divide by 2. 1 divided by 2 is half. That's a new one. 2 divided by 2 is 1. Got that one. 3 divided by 2 is a new solution. And 6 divided by 2 is 3. Already got that one. Now we're going to divide by 4. 1 divided by 4, plus or minus 1/4. That's a new one. 2 divided by 4 is a half. Got it. 3 divided by 4 would be a new one. And 6 divided by 4 is the same thing as 3 divided by 2. So there's my pool of guesses. Cool. I got the answers in the pool, the potential zeros of the function. All right, now on this one here, my pool of guesses is based on 1 and 9, so it's just plus or minus 1, plus or minus 3, and plus or minus 9. So this is my pool of guesses. So we go through synthetic division: 1, -2, 10, -18, and 9. And we guess out of the pool, and we guess, hey, does 1 work? So we do synthetic division: 1, 1, -1, -1, 9, 9, -9, -9, 0. So it worked. And then you try things again, and guess what? 1 works again. So you stack it up, and you get 1, 1, 0, 0, 9, 9, and 0. So since 1 works twice, that's a multiplicity thing. So it's x minus 1 times x minus 1. And then remember, this means x squared. And then no x's plus 9 is equal to 0. So then we do zero product property. So x equals 1, x equals 1. X squared plus 9 equals 0. So what do? We solve it. And there's no real solution. So that's the real solution. But the x squared minus 9, these are the imaginary solutions. So we're going to subtract the 9 over, and we take the square root. So we get x is equal to plus or minus 3, square root of negative is I, so plus or minus 3i. So there are four solutions because it's x to the 4th. It's just there's that repeat solution, multiplicity, and then 2 of the solutions are imaginary, plus or minus 3i. And I wrote them out fancy on the answer key. All right, so there it is. There is your video. Short, sweet, to the point. Enjoy, and good luck.